Hello, my name is Neil Shelley. I'm here to help you today understand how to repair the K-Tech family of ICB blenders. To start with, this is a representative of the family. They all look the same and they are all repaired the same. So the techniques you will learn today will help you repair every ICB family member. To successfully repair a K-Tech ICB blender, you'll need the following tools: a 3/8 inch Allen wrench or 9mm, a handheld number 2 Phillips screwdriver, a pair of needle nose pliers, either a pair of channel locks or a crescent wrench, a small flathead screwdriver, a standard hammer, and optionally you can use a power screwdriver. To begin with, you'll need to remove the screws holding the unit together. On the top there are 4 panhead screws, and on the 2 sides there are 3 countersunk screws. Remove the panhead screws first. Then remove the 3 side screws from each side. Be careful not to lose the screws. Once the screws are removed, carefully slide the back panel off of the machine and set aside. Remove the front panel by carefully lifting up and laying flat. Once the unit is open, you'll notice you have several electrical connections. To begin with, to work on either the motor or the electronic assembly, you will need to disconnect all of your electrical connections. Let's begin with the touchpad. The touchpad is held in place by this white jack. To remove the touchpad, you grasp the side of the jack and lift up. The touchpad will then come out. Next, you have these 2 connectors here, which are for your thermal sensor and speed sensor. These simply pull off and can be set aside. Finally, you have these 2 connectors for the motor. These are quick connects. Simply apply pressure downward and pull up on the wires. To repair a motor, you'll need to know why you need to repair a motor. The armature inside has 2 ball bearings on each end. Occasionally, the grease in the ball bearings will be displaced by water, coffee, fruit juice, or other liquids. When that happens, the motor will sound like this. Another problem is when the electronic assembly breaks and the motor runs at full speed. When that happens, it sounds like this. And you will need to replace both the armature and the electronic assembly. Let's begin with armature assembly replacement. To start with, you have a layer of protective foam here. Very carefully peel this free to preserve it for later reinstallment. Peel it off, set it aside. You then have this connector here. This is your speed sensor. Take your flathead screwdriver, carefully insert the screwdriver under the speed sensor and gently pry upwards. The speed sensor pulls out. Set that aside. To remove the nut from the shaft, insert your Allen wrench into the drive socket of the motor and use your pliers or adjustable crescent wrench to hold onto the nut. Then spin the nut free from the shaft. When motors are built new in the factory, there is a thread locking compound applied to the nut. Sometimes you will have to apply more force to loosen the nut. Next, remove the fan washer from the top of the fan. To remove the fan, insert the Allen wrench into the drive socket. Carefully hold the fan with the needle nose pliers, but do not bend the fan blade. As you spin the shaft, the fan will work its way to the top and eventually come off of the shaft. Set the fan aside for reassembly later. Under the fan is the fan spacer, seen here. Carefully remove it and set aside. To gain access to the armature, take your number 2 Phillips screwdriver and go down into the 2 holes here, where the screw heads are located. Carefully loosen. To remove the field assembly and bracket assembly, place your fingers here under the field and your thumbs here on the shaft and lift off as one piece and set aside. You now have the armature assembly free in the casting. To remove from the casting, you will need to remove here the sling ring. This is accomplished by putting your Allen wrench into the shaft, then pound downwards. The armature will come out, and the sling ring is left on your Allen wrench and can be reused. As you can see on this armature, there is a black rubber cup around the bearing. Occasionally, that cup will remain inside here. Pull it out, clean it up for reuse. To replace the touchpad, you'll notice that we have installed a significant amount of silicone here around the base. This is to prevent water from leaking from the other side into the motor chamber. If you find that you need to replace the touchpad, remove all of this silicone. To remove the silicone, you can scrape it free from the casing using a flat-bladed screwdriver. It is not necessary to remove every trace of silicone, simply the majority of it. When reinstalling the touchpad, there are 2 surfaces with protective tape. However, one has another small piece here. This is the side that adheres to the casting. You will place the ribbon down through the hole and place the casting in place. Re-silicone with whichever silicone you have convenient. Take your new armature and very carefully ensure that your rubber cup is installed on the bearing. Place it into the hole, and using your thumbs, press down on the rubber cup to seat it into the hole. Once the majority of the rubber cup is below the metal rim, push down to seat firmly. Ensure the bearing spins freely. Should you find you need to replace one of the carbon brushes, you'll need to begin by very carefully using your flat-bladed screwdriver to press the brass housing back. You can do that by pressing here against the bearing rest on the top of the bearing bracket. Don't apply too much force, as you can crack the bracket. Once the majority of the brass housing has been moved back, carefully grasp this motor wire here and pull it out from under the bracket. You can then carefully grasp the brush and pull it out and free of the bracket. To reinstall the brush, and this is critical to do it correctly, very carefully feed the carbon into the bracket. Very gently start the brush into there, but don't force it. Before pushing the brush all the way in, insert the copper tab under the plastic housing and on top of the brass housing. Then push the remainder of the brush in by using an upward and inward motion, as such. Now you are ready to reinstall this on your motor. Now you'll notice I have the casting positioned such that the touchpad is to my left, and that is important when you're putting this back together. This small part is called a load spring or thrust washer. It has very definitive feet, and these feet need to rest on the outer race of the bearing like this. Gather your field assembly. On the field assembly, you have this detail here where your speed sensor will rest. You will want that facing away from you when the touchpad is on your left so that it is all connected correctly. Carefully rest the field assembly on top of the armature shaft. The brushes have come together in the center, as you can see here. Use your flat-headed screwdriver to carefully pry the brushes back from each other and around the shaft. You can then continue to work it down. You can then continue to work them down around the bearing and eventually onto the copper commutator. Now, once you have this in this position, ensure that your wires are not pinched under the field and the posts, and gently press the bracket down into position. Using your screwdriver, hand tighten the two screws. Be careful not to over tighten these, as you can crack the bearing bracket, which will lead to premature bearing failure. You can do this step with an electronic screwdriver, but you must be very careful about not breaking the bracket. A critical part of this that you will see here is the spacing of the brass housing from the copper commutator. This is correct spacing here. This here is too much. To remedy that, you would simply continue to carefully push the brass housing in until the spacing is correct. To continue reassembling your motor, you will then turn it over and rest on this shaft here, like so, to reinstall the sling ring. Carefully just lay it on top, use your hammer, and gently tap it into place. What you want, the top of the sling ring needs to be flush with the top of the drive socket here. Once that's in position, turn it back over. Take your fan spacer, which has a narrow end and a wide end. Narrow end goes down. Push it over the shaft. Carefully take your fan. The fan has a points down position versus a points up position. You want it this way on the shaft. Place it over and carefully work it down over the shaft. Place your fan's washer and now the nut. You can begin by hand threading the nut, and then you will use your Allen wrench and your crescent wrench or pliers to tighten. As you put the nut on, you may secure with a small amount of thread locking compound. Hand tighten only. Over tightening the fan can cause the carrier, which contains the drive socket, to break free from the armature and spin loose. The motor is now rebuilt. Take your speed sensor assembly and slide it. There is only one direction that the speed sensor will fit into the bracket. When it is in position, it will click. Let's move on to electronic repair. This is your electronic assembly. It consists of the electronic board, the metal housing, and the power cord. We do not repair the electronic board. Instead, we replace it in its entirety. A new electronic board will contain the microchip, and therefore it is already programmed. To remove the control board, you simply disconnect these two wires here, which are your line and neutral line, from the power cord. Again, these are quick connects. They simply pull free. As always, when working with sheet metal, use extreme caution so that you don't cut yourself. Once the power wires are disconnected, use your needle nose pliers to grasp the 4 rubber standoffs on the board. By pulling up and lifting the board with your other hand, it will free the board from the standoff. Repeat for all 4. Once the board is free from the housing, you'll be left with the power switch, a jumper wire, the power cord wires, and 4 rubber standoffs. To reinstall a board, take a new board assembly. Ensure that there is a microchip already installed. If not, you will need to install one. Place the board over the 4 standoffs. Just allow it to fall over. Now, take your needle nose pliers again, carefully grasp the rubber standoff, and pull up while pushing down on the board. As you can see on this board, we have a toroid. This is part of the electronic noise filtering mechanism. When pulling on this standoff, be very careful not to damage the copper windings. Once the standoffs are all through, the board is secure. Reconnect your 2 wires. In a 120 volt application, white is neutral. In a 240 volt application, this wire will be blue. It will go on the post marked neutral. Now you take the jumper wire from the switch and attach it to line. The electronic assembly is now replaced and ready to be mated back to the motor assembly. To reassemble the motor assembly and the electronics assembly, have the touchpad of the casting on your left side so that your speed sensor is here on the front. Lay your electronic assembly facing down, and the first thing you'll want to do is reapply the heat foam. Start on the side nearest you and very loosely and carefully drape it around the top of the bearing bracket. Once it's in position, press around the bottom for a good, secure fit. Now take your 2 motor wires. As you can see here, these are both black. In some motor applications, they may be both white or they may be black and white. It is not a polar motor. Where you connect these is irrelevant. You have motor A and motor B. Either wire can go to either post. Again, these are quick connects. They simply push on. Once your motor connections are made, take your thermal sensor and speed sensor connectors. They will connect here. The speed sensor is a 3-pin, the thermal sensor is a 2-pin. There is an additional 3-pin connector here. This is for ABC models. This is where the Hall effect, which is also residing in the casting, will connect. Do not connect the speed sensor here or it will not work. Again, these connectors push on very easily. Now you will notice these wires are wrapped and these wires are wrapped. Do not wrap these 2 bundles of wires together. Keep them separate. Finally, we need to reconnect the touchpad. Open the jack by grasping the sides and lifting up. Carefully take the touchpad ribbon and push it into the touchpad connector without closing it. Once you've pushed the touchpad in, push down on the sides of the jack to lock it into place. Now, carefully lift the front housing up and set it on the casting. You'll retrieve your 2 countersunk screws and secure the housing to the casting. Next, look at your cord wires, ensure they're not trapped. Look down through the spacing between the field and the electronic board. Ensure there are no wires trapped between the heat sinks or other components. Make sure they move freely. You may also tuck your speed sensor and thermal sensor wires into the side for control mate. Take your back housing, carefully slide it on, and secure with the side screws first. Now on the top of the motor, which is actually the bottom, but it's the top while you're working on it, you're going to put your 4 pan head screws in. Start with one and squeeze and manipulate the housings to align the holes. Start at a few threads, move to the next hole. Just put it in a few threads. This will allow you to flex the housing and get all 4 screws in. Once they're in, tighten them all the way down. Now, when you initially opened the machine, you may have noticed that along this seam there was some gray latex or silicone. You can replace that as a water ingress prevention. It will prevent water, coffee, juice, those kind of things from getting into the motor. Finally, on the top of your machine, take your small flathead screwdriver and make sure that the foam is away from the majority of these vents by pushing back, like so. This will ensure the maximum amount of airflow. To facilitate the repair of our blenders, we have developed a total rebuild kit. The kit consists of an electronic board with microchip, armature assembly, brushes, fan, touchpad overlay, display label, speed sensor, and gasket. This kit will allow you to completely rebuild every motor. What we have found here at Blendtec is that by rebuilding our motors, they last longer. It is strongly recommended that you use this kit, regardless of the failure of the machine, to ensure your customer is happy with a quality repair. The bottom of our blender jars contain an assembly that also have a bearing in them. The most common failure for blender jars is bearing failure. When a bearing in the jar fails, the jar will become very loud, the shaft will become very loose, or it may become very tight. As an example, this represents an example of a wobbly shaft. As you can see, this shaft freely moves side to side and back and forth. The bearing in this particular jar is no longer of any use. You may also notice a significant amount of rust around this portion of it. We do not repair our jars. We discard them and replace them with new jars. This concludes our repair video on the ICB series of blenders. Should you have further questions or require parts, feel free to contact us at one of the email addresses you now see on the screen. Thank you.